All right, this is section 4-4, using corresponding parts of congruent triangles. All right, let's start off with a review of vocabulary. So we're going to first underline the correct word or words to complete each sentence. So number 1, the reflexive property of congruence states that any geometric figure is congruent to itself. The reflexive property of equality states that any quantity is equal to itself. Circle the expressions to illustrate the reflexive property of equality. So A equals A is the reflexive property of equality, and 5 plus C equals 5 plus C is the reflexive property of equality. So now we're going to circle the expressions to illustrate the reflexive property of congruence. Angle ABC is congruent to angle ABC, and line segment CD is congruent to line segment CD. All right, so vocabulary builder, we're going to talk about proofs. So a related word is to prove. The definition of a proof is convincing evidence that a statement or theory is true. In math, we use a proof as a convincing argument that uses deductive reasoning. Okay. So as we saw with our activity that we did, inductive reasoning is where we explore and we come to a conclusion. Deductive reasoning is we go to a step-by-step approach using mathematical logic that gets them from point A to point B. So use our vocabulary. In number 5, in geometry, a proof uses definitions, postulates, and theorems to prove theorems. No one can prove how our universe started. He can prove when he bought the computer because he has a receipt. Okay. All right, let's take a look at number 8 here. We're going to complete the steps in this proof. So we are given that line segment AB is congruent to line segment AD. Line segment BC is congruent to line segment DC. Angle D is congruent to angle B, and angle DAC is congruent to angle BAC. And if you notice, all of those markings are in here. So the first time it comes up, it's 1 mark. The second time, it's 2 marks. Okay. And we want to eventually prove this top triangle is congruent to this bottom triangle. All right, so let's see what we got in our proof. We know from the given, line segment AD is congruent to line segment AD. Line segment BC is also congruent to line segment DC. And that is our given information. Well, we also know that line segment AC is congruent to itself by the reflexive property of congruence. We were told angle D is congruent to angle B, and angle DAC is congruent to angle BAC. C. And that was given. Now, if I know 2 angles are congruent, I also know that the third angles must be congruent. So angle DCA must be congruent to angle BCA, and that's by the third angle theorem. Now notice, you have 1, 2, 3, 4, 5, 6 pieces of information, all 6 pieces of information about these 2 triangles. So therefore, triangle ABC is congruent to triangle ADC. All right, and that's by the definition of congruent triangles. So that is proving everything is congruent. And this is an example of deductive reasoning. We use step-by-step reasons to show a proof. All right, so here's problem number 1. So we're given some more information. We're given BA is congruent to DA. We're given that CA is congruent to EA. And we want to prove that angle C up here is congruent to angle E down here. So name 4 ways we can use congruent parts of 2 triangles to prove the triangles are congruent. Okay, so notice we have these 2 triangles. We can prove 2 triangles are congruent if I have SSS, if I have SAS, if I have ASA, and if I have AAS. So to prove 2 triangles are congruent, when you know 2 pairs of congruent corresponding sides, I can either use SSS or SAS. So I need to choose in my picture which is more plausible. Am I easily able to prove that CB is congruent to ED, or is there an angle I might be able to show is congruent? And that's going to tell me which direction I want to take my proof. So the given states And the diagram shows that there are two pairs of congruent sides. And I'm thinking I'm going to add a very slight piece of information that these two angles are going to be congruent by vertical angles. Okay. So here's our proof. Line segment BA is congruent to line segment DA. And the reason I know that is because it was given to me. I also know that line segment CA is congruent to line segment EA, and that was also given to me. Now, I just marked this in the diagram. Angle CAB is congruent to angle EAD, and the reason I know that is because of the vertical angles are congruent. Now, I have S, I have A, and I have S. Okay. So I know these two triangles are congruent by SAS. Now, if I have two congruent triangles, then I know all parts must be congruent. So therefore, I know angle C is congruent to angle E. And that is by corresponding parts of congruent triangles are congruent. Now, another way we can state that is by using a symbol called CPCTC, and that's what that stands for. All right. So let's try this again. Here's another proof. This is a flow proof. So if I'm given that AB is congruent to AC, and I know that M is the midpoint of BC. So if I know this is the midpoint, then by definition of midpoints, I'm going to be able to prove those are congruent. And by reflexivity, I think I could prove these are congruent. So I have SSS case here. And that's going to show me I have two congruent triangles. Therefore, I can easily prove that angle AMB, this angle here, needs to be congruent to that angle there. So I'm given AB is congruent to AC. I'm given M is the midpoint of line segment BC. And I'm given AM is congruent to AM, reflexive property. Now, since M is the midpoint, definition of the midpoint creates two congruent segments. So I know BM is congruent to CM. That's what I marked on the diagram there. So this is my 3 tick marks that I marked. This was the 2 tick marks that I marked. So I have SSS, 3 sides of the triangle. So these 2 triangles are now congruent. The triangle AMB is congruent to triangle AMC. Now, since I have congruent triangles, I know the rest of the parts must also be congruent. So by CPCTC, angle AMB must be congruent to angle AMC. All right. So here's a diagram. Name the postulate theorem that you could use to show these 2 triangles are congruent. Then explain why EA is congruent to MA. All right, so circle the angles that are marked congruent from the figure. So angle ETA is marked congruent to MTA. Circle the sides. ET is congruent to MT. And then reflexivity, I also know AT is congruent to AT. So look at this. By the diagram, I have SAS. So by SAS, I'm going to be able to prove these 2 triangles are congruent. So therefore, any remaining parts of the triangle must also be congruent by CPCTC. And that's the abbreviation we use. Corresponding parts of congruent triangles are congruent. Okay, error analysis. Find and correct the error in this proof. So we're given that KH and NH are congruent. Angle L is congruent to angle M. All right, do we know anything else? We want to prove that H was the midpoint of LM. Okay, I think I have vertical angles, don't I? Right off the bat. Then by AAS, I have congruent triangles. If I have congruent triangles, then I'm going to be able to show that this segment must be congruent to this segment, which means H must have been the midpoint. Okay. So basically that's what we have here in the proof. All right, KH is congruent to NH because it's given, L and M because it's given. But I also know these angles are congruent because of vertical angles. So we have congruent triangles by the ASA. I'm going to change that. That should have been AAS. Since corresponding parts of congruent triangles are congruent, I know LH is congruent to MH. So by definition, midpoint, I have LM. Okay, so place a check next to the correct statement. Okay, this is correct because of vertical angles. This was not correct by ASA. It was AAS. Okay, when you name congruent triangles, you must name corresponding vertices in the same order. To use the ASA postulate, you need two pairs of congruent angles and a pair of included congruent sides. To use AAS, you need two pairs of congruent angles and a non-included side. So identify the error in the proof that was written above. So we have triangle KHL is not congruent to triangle MHN. The ASA postulate cannot be used to prove the triangles congruent. What we should have proved was triangle KHL is congruent to triangle NHM by the AAS theorem. All right, and that's the end of this section.